There we go. Whoops, can you see me? Dang it.
Hello, welcome in. Oh my gosh.
Can you
Yes,
turn?
feel free to populate the left half. Yeah, and
Whoops.
actually, probably one of the first things we'll do is ask you to just like turn to the person on your left or right and introduce yourself. Yeah, typically 106L is it's like a class taken by people who are just really interested in learning more about like C++ or whichever. So it tends to be like a really nice like close knit community. So we're gonna hopefully continue that this quarter. Oh, what are all your names? Hannah?
I'm Sylvia.
Sylvia?
Sonia.
Sonia. Okay. And Glenn. Okay, perfect.
Totally forgot I left my food outside. I was too excited about the class that I left my food outside.
And you're doing design philosophy.
Yeah. I'm gonna go through it really quickly.
Perfect. Did you?
Yeah, everything's done. Everything is fine. This one, right? Okay.
Oh, hello. Welcome in. Welcome in.
All right. Okay, so if you're ready here, let me just pull up the Piazza
The
page.
Piazza, nice.
Yeah, so we're mostly going to use Piazza for questions in this class. So here is our Piazza page. Yep, it's at the very bottom.
Yes.
It's
right here.
yeah, it's exactly what you would expect it to be.
Yeah, and this is where we'll post things like any modifications to the assignment handout, or reminders for things like filling out surveys, which will give you late days, things like that. Yeah, and then of course we would love it if you ask like any and all C++ questions on the Piazza. Yeah, like Avery and I are super happy to answer any questions, even if it's not necessarily related to things we've covered in the class. Yeah, this class is really an opportunity for you guys to just like explore the language with us. So if it's something you've seen in say 106B this quarter, also feel free to ask about it. Yeah. Yes. So one more time, go to this link to join the Piazza for the class. Oh, hello. Welcome in.
Yeah. Also, please move towards the front. We accidentally got a gigantic lecture hall, so please move to like the front row or so. Please move forward. Like we don't bite.
Just Avery.
Just me.
Sometimes.
Yeah. But yeah, I'm really hungry right now. But yeah, please move forward because this lecture hall is really big and we want to interact with you. Our lectures are mostly interactive, so move forward to the front. Don't sit in the back.
We promise we'll eventually know all of your names.
Yeah.
Hello, welcome in.
Yeah, and also move towards the front, please. Please move more towards the front. All right, I'll start like 1:35, 1:33.
You can just start
Few
at
minutes,
2:30.
2:30. Okay,
At the beginning.
sure.
All right. Okay. So we still have a minute before class starts. So if you guys could take this chance,
Oops.
and look at the person to your left or right and introduce yourself. Say like maybe your year, what you're studying. Yeah, get to know each other. Definitely know each other's names at the very least. Oh.
I'll remember you.
Feel free to move up as well if you like.
Well, since I'm a freshman, I still know, but yeah, how about you? Well, actually, like during my high school career, that was actually high school.
Oh, hello, welcome in.
Yeah.
Welcome in. Sit anywhere in the front.
Yeah, please sit in the front.
And then I switched to CS. I was actually a math student, so it went kind of full circle there.
Okay, do you want to start?
I'll start, yeah. All right, so we'll come back to this page like later, but let's get started. So, yeah, we have a lot of slides. Let's see. Okay, everything is set. Okay. All right. Hi, everyone. Welcome to CS 106L. All right, so, yay.
Oh, hello, welcome in.
Yeah, okay, so what are we going to do today? So today we're going to first welcome you all to CS 106L. We're going to talk about why C++. Out of all the languages that there exist, why is C++ important? And then we're going to ask, okay, then why take CS 106L? How does CS 106L fit into your long journey at Stanford here? Okay, we're going to talk about that. Then we'll go through some logistics about what this class is about, what the requirements in this class are, and then we'll dig into the history and philosophy of C++. All right, Anna will go into that, and then at the very end, if we have some time, we'll go into some basic C++.
Sample program.
Yeah. Yesterday, if you were in Keith's class, he did a brief intro to C++. We're going to introduce the other part.
The counterpoint, sort of the modern version of what Keith did in class.
Mm-hmm.
Yeah.
Okay, let's get started. So, just an introduction. These are our photos.
Yes,
introduce you?
hello, nice to meet you guys. So my name is Anna. I'm one of the 2 co-lecturers for 106L this quarter. I'm currently a senior studying computer science with a focus in systems and also interested in cybersecurity. So if you're interested in any of those, feel free to talk to me about that outside of class.
All right. Hi, everyone. My name's Avery. That's me holding a stuffed alligator. Yeah, so I'm a junior right now. I am a math major, although I'm probably going to do a CS and co-term in CS. So feel free to ask me about that. Yeah, we love teaching. In the past, we were both section leaders.
Yeah. For the CS 106 program. So.
Mm-hmm. Yeah, so feel free to ask us anything about CS 106, CS 106, CS 106B. How to apply to be a section leader,
How to apply to be a section leader.
Yeah,
yes.
which we will talk more about later. But yeah, so that's just a quick introduction to ourselves. Let's talk about why C++. Okay, so how many of you are in CS 106B right now? Okay, so a big chunk of you. And then, okay, how many of you took CS 106A in Java? Okay, 106A in Python? Okay, I see. So, I mean, a lot of the 106B students right now took 106A last quarter. So last quarter you learned Python, but then you might be wondering, okay, we have a good programming language. Why do we want to learn another one? So contrary to what a lot of people might tell you about, oh, C++ is a dying language, Python is the new language of the world, that's simply not completely true. C++ is still a very, very popular language. Especially in the most recent years, they've been undergoing major changes to the language to make it much easier to use. So because of that, C++ is still growing in popularity. Yeah, so C++ bounces back at Python's expense.
There's no war between C++ and Python, we swear.
Yeah.
It's just an internal one.
Yeah, although I did go to CS41, the Python class yesterday, to try to poach students. Didn't quite work. But yes, classes that use C++. So there are a lot of classes which use C++. And in fact, a lot of these classes that you'll notice is a lot of the applications of C++ are really performance related. So you can see like there's a lot of like parallel computing, computer networking. A lot of these classes use C++ because C++ is a very strong performance language. Companies that use C++. The biggest question we always get is, will C++ help me get a job? And the answer is definitely yes. All right. Pretty much every company uses C++ somewhere. And in fact, if you go to Handshake and if you type in C++, you'll get thousands and thousands of results. Okay, so just a fun fact. A lot of browsers are written in C++. Do all of you use one of the browsers up here? Okay, yeah. So you might have heard that browsers are just really, really hard to program, and they're all written in C++ because performance is important. Do you want a slow browser? You do not. So that's why a lot of the browsers are written in C++. Software in C++. I always found it really funny that Java is actually implemented in C++. So if you are using any languages, I'm not sure if Python, is Python implemented in C++? Okay.
No.
Okay, it's not. Aw, too bad. But yeah, Java is written in C++. A lot of the software tools that you've used, they're all written in C++. Games. A lot of games are written in C++. Right? So if from what you know about gaming, when you are playing these games, these are like pretty intensive. These games use a lot of memory. If you've ever tried running a game on your laptop, if your laptop's not good, your laptop is considerably slow. And to be able to combat that, a lot of these games require really high performant languages. You'll notice I keep saying high performant, and because that is one of the biggest strengths of C++.
And we'll delve a little deeper into what exactly high performance means, actually just later in this lecture when we talk about the history.
All right, so fun fact, C++ exists on more than one planet. Okay, so there's a Mars rover. Is it still operational? I don't think it's operational anymore, but there's still C++ code in that right now. And there's probably some other rover with more C++ code as well. A lot of these Mars rovers, a lot of these aircrafts, they have code in them which is written in C++. Okay. Okay. Every quarter I try to pronounce this guy's name and I always fail. How do you pronounce it?
Bjarne Stroustrup?
Bjarne Stroustrup.
Probably.
Okay. We're just gonna call him like he's the father of C++.
Which he is.
Mm-hmm. Yeah. If you go online, if you see anything written by him, people respect it a lot. He not only was the guy who developed C++, but he also has written like what the core philosophies of C++ are. So we'll be reading a lot of stuff written by him. But this is like one of the quotes he gave. It's too long to read, so I'll let you read it later. But now you want to ask, okay, well clearly C++ is important. Why do you want to take 106L? Doesn't 106B teach C++? So we're going to just do a quick comparison of what 106B is and what 106L is. So 106B is called programming abstractions. You'll notice that C++, the language, is not written in the name. C++ is not the most important aspect of 106B. The goal of 106B is not to just learn C++. Right? The goal of 106B is to learn programming abstractions. You'll learn more what that means soon in 106B, but even though we give you a basic introduction to C++, you're learning just enough to actually write meaningful programs, using stuff like recursion, using ADTs, using data structures like linked lists and binary search trees. C++ is a tool, but C++ is not the focus of CS106B. Okay? On the other hand, in CS106L, our goal is to teach you standard C++. Okay? And one way you can see that is, let me just go through. No, I'll mention that later. But yeah, CS106B, because C++ is not the goal, your goal is to learn programming concepts that are important across all languages. CS106B is quite language agnostic. Even if you have never used Python or some other language before, after learning C106B, the goal is you can probably transfer the knowledge to some other language. Okay? But most things we learn in CS106L are directly applicable to C++. We'll in particular focus on what makes C++ very unique. Okay? One of the biggest parts is templates. In CS106B, you learn barely enough C++ to learn the greater goal of programming abstractions. But in CS 106L, we'll teach enough C++ for any job, any internship, any research that you do. We're not gonna teach you the entire C++ language, but we will give you some basic familiarity with some key concepts so that you can easily Google some stuff about C++ if you want. In CS 106B, the version of C++ used is C++ 98. And any guesses as to when that came out? 1998, okay, which was before I was born. So yes, this is a very, very old version of C++. It's sad to think that C++ hasn't evolved since then. Well, it has, but 106B doesn't really adopt it. So in CS 106L, we'll be learning stuff from C++ 17. Any guesses as to when that came out? 2017, yeah. And in fact, there's a new standard coming out this year called C++ 2020. And that C++ 20 is pretty revolutionary in terms of the changes it has brought. The last major change was C++ 11, 9 years ago, and now they've been revamping it even more. One thing about CS 106B, which I don't think Keith has covered this yet, but in CS 106B, you will be using the Stanford libraries because C++ is a very messy language. Okay. Next lecture, we'll be talking about streams, about how do you get user input. User input is really, really complicated, as you'll learn next on Thursday. So what the Stanford libraries do is they abstract away all the messy details so that you can just call a function called getInteger. Keith hasn't used getInteger yet, right? Okay. Well, in the Stanford libraries, there's a function called getInteger, which does exactly what you think. Okay. But then to really understand C++, you want to dive deep into what these messy details are. How can you learn the underlying of how does getInteger work so that you can write your own functions? Yeah, so in CS106B, if you go to any section leader and you ask them, how do I use cin? They'll tell you, please don't use cin, just use getInteger. Okay? But in CS106L, we will actually learn how do you tame cin. Yeah, quick tip for assignments in 106B. Do not use cin. Okay, if you use cin, you will likely
a bug that will take quite a few attempts to debug.
Yeah.
Based on experience. So.
Mm-hmm. Yeah, cin is very tough to use. We'll see that on Thursday. So if you go to the lair, if you ask your section leader, and if they see you using cin, they'll just tell you, hey, use getInteger. Cin is really hard to use. Okay.
But now you guys will know how to use it, so you guys will actually be ahead of the curve.
Yay. But still, don't use it on exams, please.
Yes.
Okay, what's the goal of CS106L? We have 3 major goals. First goal, learn what features are out there in C++ and why they exist. Okay? Because Google is so available right now, there's no real reason to memorize everything. But one nice thing to know is you should know what features are out there so that when you do need to use some of these features, you know that that's a feature and you can Google it. Okay, so we'll be exploring what are the cool features in C++. Another thing we want to do is talk about how do you read C++ documentation, because here's an example of how you declare a vector in C++. Okay, so if you're not familiar with what a vector is kind of in Java it's an array list, in Python it's just a regular list. So to create a vector, there are I think 12 different constructors you can use. Okay, you should know the first one. The first one just creates an empty vector. But then you'll see all of these like weird vectors. There's a fill vector, a range vector, a move vector. There's this thing called an initializer list. What the heck is that? And then you'll see these like, these weird types, these ampersands. Keith will cover what 1 ampersand means, but you might sure wonder, what does 2 ampersands mean? Okay, we're going to cover all that. You'll be able to read this C++ documentation, no problem. Okay, any questions so far? Cool. Yeah, by the end of 10 weeks, we'll see what means. Okay. And then the last part is we want to become familiar with what the design philosophy of modern C++ is. There are some like common idioms, common design choices that modern C++ people use, and we're going to explore what those are. The key part is to not memorize the syntax of C++, because there's just so much syntax that it's really hard to memorize. But you just need to know what the syntax is used for and how do you find it. Okay, here's a fun little graphic of what we're going to go through. We have 4 major units. We're going to first talk about C++ fundamentals. Then we're going to explore the standard template library, which goes through, which gives you a good overview of what the collections are, what the iterators are. Then we'll talk about object-oriented programming. And then finally, we're going to explore some really modern C++ concepts.
Yeah, and one side note is one way that we often use to pitch 106L is that we say it's really useful for coding interviews. And the reason why we say that actually comes out in that second unit, the standard template library, where you get to learn about all of sort of the built-in tools that C++ has for you already. So these are things like algorithms that C++ has already implemented in the fastest way possible. Things like that. So yeah, so to sort of summarize, there's sort of two big goals that we want you guys to take out of this. One, of course, is just to show how cool C++ is and give you guys an idea of all the features there are out there. And then the other one is to make sure that you guys feel as though you can build a program from scratch and sort of feel as though you can write a real program yourself, which is something that I know I didn't necessarily get out of 106B.
Mm-hmm. Yeah. For example, if you're looking for like a summer internship, that orange, that yellow bubble over there will cover everything you need to know for like programming interviews for a real job. So just some basic logistics. Our lectures, they are I still don't know if bi-weekly means twice a week or 2 times or once every 2 weeks. But yeah, they're gonna happen twice per week in this room, Tuesday, Thursday, 1:30 to 2:20. You'll notice that this slot is booked for 1:30 to 3, and that's not an accident. We're probably, for one of us, maybe both, are gonna be here from 2:20 to 3. So this will act as our office hours. If you have any questions about the assignment, if you have any questions about C++, any questions right after lecture, feel free to just ask us during that time, okay?
We'll also have a couple of additional office hours in case you can't make that time.
Our class website is CS106L. It's written up here. It's basically CS106B, but you just change the B to an L. We haven't updated that website yet, but we will get to that by tonight, so you'll be able to see the new website. Getting help, we have office hours, we have Piazza. Please don't use Lair, because one thing about these section leaders is these section leaders are not required to know standard C++. A lot of them aren't even CS majors, so they might be stumped if you ask them a standard C++ question. So avoid using Lair. Feel free to email us, go to Piazza for questions. For assignments, there are 3 total assignments. You have to complete 2, and the 2 must include the last one. Okay, so just so that's clear, okay, there are 8 possible different ways you can do the assignments. Do none of them. If you do none of them, you won't pass the class. If you do all of them, you'll definitely pass the class. If you choose to do 2, you can do the first one or the third one, or the second one and the third one. You have to do 2, and it has to include the last one. Make sense? Yes? Yes. So just to reiterate, you can't do the first one and the second one. You have to do the third one.
And part of the reason behind that is that the point of the assignments isn't necessarily to challenge you with like a tricky algorithmic problem or something like that. The point of the assignments is really just to give you some hands-on practice with just the C++ syntax. And so part of the reason why we want you to complete the last one is because by then is when we'll have covered pretty much all of the topics that we'll have wanted to cover. So that will give you the most practice with what you've learned in the class.
Yeah, just a quick overview. The first assignment covers the red bubble, second assignment covers the yellow bubble, the third assignment covers the last 2 bubbles. Okay, because the third assignment is so important, it covers 2 bubbles, so you have to do the third assignment. Okay? Of course, we recommend you do all of the assignments, obviously. Okay, late days. So by default, we're not giving any late days, but you can earn up to 3 late days by completing surveys. Okay, so we're gonna send out a survey. If you fill it out, wait, is there a name field on that survey?
Yes.
Okay, last quarter we forgot to put a name field. So someone asked, how do you figure out who gets late days?
We just know, we read the patterns.
Yeah, so yeah, don't worry. Oftentimes the surveys, the first survey is used for just to give us an overview of what your backgrounds are, and then later surveys are for feedback for what you want to see in the class, okay? Your name is not necessarily directly tied with what your survey response is, so don't worry about that.
Yeah, we also want to emphasize that, like, we know this is a 1-unit class, and again, the point of this is not to give you more work, it's just to give you some hands-on experience. So, like, if you have other circumstances, feel free to talk to us, and we can definitely work something out. Yeah, so don't ever, decrease your mental health because you're worried about CS106L.
For development, our platform we're going to use is Qt Creator. I know some of you are going to ask, okay, can I use some other platform? Mm-hmm. Okay, and basically for our assignments, the first 2 assignments, the first assignment uses a graphics library, which is specific to Qt Creator. The second one uses a networking library, which is specific to Qt Creator as well. So for the first two assignments, you can't. You have to use Qt Creator because unfortunately C++ doesn't actually have a built-in graphics library yet. C++ 20, there's going to be a graphics library. The third assignment, we're still fine-tuning the third assignment, but my plan is to allow you to use some other developing software if you choose to. Sometimes during like examples, we might be using some other environments just so you can see how C++ works in other environments outside of Qt. Cool. Let's see. Honor code. Any questions? Yeah, feel free to ask us any questions. We love answering questions. All right, honor code. Same rules as with CS106B. Don't cheat. Okay. The more specific rules you can read online. Basically, the assignments are individual. We don't foresee that these assignments are going to take too much time, so we want you to do it individually. They're mostly for your own practice. Don't Google CS106L assignment 1 and try to find the solutions to them. Just don't cheat. Do it for your own learning. Okay.
And then one important thing is, if you weren't here earlier, one more time, this is the Piazza link. You have to go there and manually join yourself. And again, this is where we'll be posting things like assignment updates, like office hour changes, any announcements that we make. So it's important that if you want to take the class that you join the Piazza. And the slides will all be posted on the course website after class. So if you miss it now, you can always go back to the website.
One more thing to note, lectures go up to week 9. Okay, we know you probably have a lot of final projects week 10. We have final projects in week 10 too. So our class will end after week 9. Okay, so we'll give you that last week to work on other projects.
A true dead week is what we call it.
Yeah, probably finish CS106B assignments. Okay, Qt Creator setup. We use the same setup as CS106B. So on the CS106B page, you can see there's a troubleshooting session, Thursday, January 9th, 8 to 10 p.m. at Lair. Does anyone know what Lair is? Okay.
Who doesn't know what Lair is? Okay, yeah, so Lair is the place where office hours for all of the normal CS106 classes are held. It's the place that we told you not to use for troubleshooting help with 106L, the only exception being for setting up Qt Creator. So it's the location of the Lair is in Trester Student Union, sort of where Decadence is. There you should be able to find a computer that allows you to sign up for help, and there will be section leaders walking around in case you can't find it. Yeah, and also feel free to message us on Piazza if you have any trouble with that. Yeah.
If I set up Qt Creator last year, has anything changed since then?
Yeah, so I think right around Christmas, they released a major update which fixed a really annoying bug in Qt Creator. So I recommend, you might not have to uninstall the whole Qt Creator. I think there's probably like an update application thing you can try. So definitely just try that. If your Qt Creator is really old, like more than a year ago, you might want to just uninstall everything and reinstall everything. Okay,
Yeah.
Shouldn't take too much time.
And we'll send out instructions for how to access like the Qt upgrade panel. Yeah, in case that helps.
Yeah, and just to be completely honest, if you ask us about I have a Qt Creator bug, what do I do? We'll probably say, have you tried uninstalling it and then reinstalling it? Okay, it's like one step above turning off the machine, turning on the machine. Okay, yeah, Qt Creator is really weird. Usually uninstalling and reinstalling will fix something.
Yeah, and just to clarify, the troubleshooting is like if you don't have Qt Creator set up, then this is the 106B website, 106b.stanford.edu, and on the right-hand side is a link that says setting up Qt Creator, and that actually has very detailed instructions of how to set it up. So if you follow that, you actually should be fine. You shouldn't encounter any bugs. This session is only if, while following that, something goes wrong. Yeah.
All right, just logistical comparison. CS106B has 3 lectures a section per week. If you're in 106B, you should still go to those. CS106L doesn't replace anything from CS106B. Okay. There have been students who treat 106L as a section, and they don't go to their section. Make sure you go to that section as well. CS106L is a 1-unit class, take in, pass, fail. Auditors are completely welcome. Okay. CS106L, 3 assignments, let's choose 2, must include the last one. We have no exams, no section. 106B has 8 assignments. Wow. Okay.
Awesome. Yeah. So that pretty much covers all of the logistics of the class and our pitch for why we want you in the class. So does anyone have any questions up to this point? Okay, perfect. Yes, so in that case, then something we wanted to do, again, one of the points that Avery pointed out as one of our goals for you to take away is not only sort of the syntax of C++, but also the design philosophy behind why C++ was designed this way. One of the nice things about C++ is that it's still very much a living language, as you can see by the fact that we have so many sort of new years of C++. And so because of that, it also has sort of some design decisions that come as a result of that history. So this is just going to be a brief overview. You might actually find this repeated in some other classes that you guys take later. So yes, welcome to CS106L. So I guess welcome to your first introduction to standard C++. Yesterday, I believe Keith ran you through a brief intro program using Stanford C++. This is pretty much the equivalent using standard C++. And you'll notice there are a couple weird syntax things that you might not recognize, including, say, this std : We'll actually be getting into all of that very soon, so you'll become very familiar soon. One of the big points about C++ that sort of influenced the way that a lot of things are designed today is the fact that C++ was inherited from other languages and therefore had to be backwards compatible. And so as with what happens a lot of times when you have to make things backwards compatible, that means that C++ has some really messy things that it can do. So for example, this is sort of the standard way that we would write hello world in C++. It turns out that this is also a standard way to write hello world in C++. Although I sort of lied, it's not necessarily standard because if any C++ programmer saw this, they would be like, what the heck are you doing? It turns out that this is the standard way to write hello world in a language called C, which we'll get into really soon. Unfortunately, this is actually also a way to write hello world in C++. Which is to say that C++, because it's backward compatible, actually has a lot of sort of, I guess on the plus side is very flexible. If you wanted to write your code in a language called C or a language called assembly, you could, but it also means that sometimes when you're surfing the internet, you might see terrible things like that. So to give you an idea of sort of what that is in case you haven't seen that before, so once again, that last example was an example of something called assembly. Assembly is sort of the way that is sort of the language that your computer understands. You'll notice it's much more complex and not at all human readable, which is what we're used to with something especially like Python, which you might have seen before. So where did assembly come from? Well, assembly was the original way that people could communicate with computers. So it had unbelievably simple instructions that you saw on the previous slide. It was extremely fast because you were just communicating directly with the computer. Notice the parentheses when well written. That's not necessarily easy to do or always the case. And finally, assembly does give you complete control over your program. You are literally, as a programmer, directing where to put what piece of memory at what point in time. So given all of these benefits, why don't we use assembly for all of our coding projects? Does anyone have a guess? Go for it, Mustafa.
Very hard to, like complex ideas are very hard to code into assembly.
Absolutely, exactly. So yes, not at all a trick question. Sort of the short answer why we don't use assembly is because it looks like this. So I guess to simplify, yes, it has simple instructions, but that means exactly as Mustafa said, it requires lots of code to do simple tasks, and it's hard to understand other people's code. Additionally, one other reason that people don't often think about is the fact that this assembly on this page is actually specific to whatever specific computer or operating system you're using. So your code when written in assembly is not at all portable. And that became an issue as people wanted to share their ideas and build more complex ideas. Which brought us to the invention of C. Again, our status was writing assembly is too difficult, but the only language that computers, these machines, actually understand is assembly. And so what do? Why don't we separate those two functionality into two different parts of a program? On the one hand, we can write code that makes sort of English sense to us, the programmers that are writing it. And on the other hand, we can use another program to then translate the words that we're writing into this one language that our computers can understand. And this is actually something that you'll learn about in future classes if you continue to take more CS classes called a compiler. So yes, we will be focusing on the first one, which is exactly what C is. So C was invented by, this is all just for historical knowledge, so you can drop it at your next party as a fact. C was invented by Ken Thompson and Dennis Ritchie, created in 1972. And yeah, one more time, the benefits of C were that it made it easy to write code that was fast, still simple, but this time cross-platform and with human readable. And in fact, if you continue on with CS, then the next class that you'll be taking after B is CS 107, and that's where you'll become very familiar with C. Yes. All right. Okay, so one more time. So at this point in history, we have C. So what else do we need? Again, C has its own weaknesses. Sort of going back to the idea of wanting to build more complex ideas, C doesn't have any objects or classes. And to emphasize why that's really important, you can imagine, say you wanted to build your own program called like Bookface, I think is a common example that people use. Then imagine if you wanted to write it and you wanted to keep track of all of this data that you have. You know that, for example, there's, say, a person on your platform that has a birthday, friends, things like that. In C, there's no such idea of having an individual object. If you wanted to keep track of all that information, you would have to manually each time just maintain, for example, an array or a list from Python of all of those different details. And so that was one really big difficulty with C, is there's no way to sort of abstract away the idea of an object or a class. It's difficult to write code that works generically, and again, overall, tedious when writing large programs. And yes, I see a question.
Aren't structs part of C, or is this something that they added later?
No, that's a great point. Yeah, so in C, there's actually something known as a struct, but a struct has its own weaknesses. So a struct is exactly available. We'll actually cover some of the weaknesses when we talk about classes in standard C++ later. But yeah, and one way to think about it is, in a sense, you can sort of think about a struct still as like just a list, sort of like an open public list that you have to maintain without any sort of complex functionality. Yeah, a great point though. Yeah, any other questions? This is sort of like a brief overview of all of the history. So, okay, awesome. So, welcome to C++. So this is sort of the current state of the art along this line of programming. So yes, going back to the father of C++, Bjarne Stroustrup invented C++ in 1983. And again, we still wanted a language that was fast, simple, and cross-platform, but we also wanted a language that had high-level features. So C did the first three, and then Bjarne created C++ to add the functionality of the last one. So because of this, a lot of people originally thought of C++ as just C with classes. It just added this new functionality of being able to view your code as in terms of objects or classes. But over the years, C++ has grown into a magically very flexible, widely complicated language that has more features than you'll ever know how to use or will ever want to use. But fortunately, what we want to do in this class is to highlight what are the most useful and most commonly used in industry features of C++. And yeah, so the ones in yellow are sort of the major updates to C++ over the years. A lot of what Stanford uses in its intro-level classes is C++ 98, as Avery mentioned. In industry, though, for any company that really uses C++, you'll pretty much only find modern C++isms in C++ 11, 14, or 17. So that's what we'll be teaching you guys. And C++ 20 coming up. Yes, and we are now in 2020. Cool.
Okay, let's just quickly go over the design philosophies of C++. We have 17 minutes left. Okay, we can do it. All right, so here are the design philosophies. The first philosophy is allow the programmer full control, responsibility, and choice if they want it. Okay, so if you don't want it, then you can, then you don't necessarily have to take all this full control and responsibility. But as a programmer, you are allowed to do a lot of different things. So for example, one thing that you'll learn later is called is memory allocation. in C++, you have to allocate memory yourself. Okay, so if you're creating like a vector, if you are writing like the vector class, you have to actually allocate the memory to put your variables in, to put your different members in. You have to do it yourself, and you have to remember to free it later. Okay, this is a big difference compared to Java. In Java, everything is kind of hidden from you. You don't necessarily have to deal with memory yourself. In Python, you definitely don't have to deal with memory. Okay, so in C++, if you want full control, like control how memory works, control how pointers work, C++ allows you to do that. And that's actually one of the reasons why CS106B uses C++, because CS106B kind of wants to dig a little deeper into how do you implement low-level features, and C++ lets you do that. The second idea is we want to express ideas and intent directly in code. Even though C++ gives you full responsibility, but the code is meant to be written so that you can actually fully express all the ideas and intent in code. Okay, there are a lot of times where like the idiomatic version of C++, the way that you should write C++ code is going to emphasize, oh, you write it this way to emphasize some sort of intent. Okay, one example we're going to give later is const. Keith hasn't talked about const probably, right? Yeah, Keith will talk about const next week. And then the key idea of const is to express intent. Let's see, what is this? Oh yeah, another reason about expressing the intent is here are 3 different ways you can find a sum of a vector. Okay, so if you look at the first one, you'll see, okay, you're doing a for each loop over like a vector. You're adding up the sum. Okay, the first one makes sense. Going through the vector, adding everything up. In the second example, you'll notice that there are slightly different. There's a slight modification, which is you'll notice the word const and you'll notice the ampersand. Okay, these 2 programs work basically the same, but the second one expresses intent better. Okay, the second one is specifically saying, oh, we're not actually changing the values as we iterate through the vector. Okay, now the third version that we're going to promote in this class is the third one. This uses this STL function called accumulate, which expresses intent the best, right? We are accumulating over the entire vector starting from 0.
Yes, and by week 3, I believe, you should understand every part of this line right here.
Okay, so this is just a full example of what expressing intent means. All right, third one, enforce safety at compile time whenever possible. What this means is when you press the compile button, the compiler should be really good at checking mistakes for you. Okay, when you get to CS107, the C compiler does not check for mistakes really well. So oftentimes the program compiles, you run it, and something doesn't work, and you have no idea why. The goal of C++ is to be able to fully enforce, not fully, but to enforce as much safety at compile time whenever possible. So if you try to do things like try to convert for example, a double into an int without, like, by accident, C++ will try to warn you when you have like type mismatches. Fourth one, this is really important, do not waste time or space. There's this really cool thing that I like to go to, C++ modern design. Okay, if you Google design principles, principles. If you go to here, you'll be able to see, where is it? Oh, here, core guidelines. Yeah, if you go to, so here is like the master document of what are the guidelines to using C++. Yeah, now there's just so much stuff in here, but one of my favorite ones is, there's one in philosophy. Let me find it. Here. So, P9, do not waste time or space. Why? This is C++. Okay, so the underlying understanding of C++ is we want to do everything possible, even if it seems kind of crazy, to make everything as fast and as efficient as possible. Okay, and that might mean doing more complicated things, managing things your own, but everything is done for the intent of not wasting time or space. Okay, this theme will come up again and again and again. A lot of things in C++ 11 is to save time and to save space.
Yeah. And this is what we mean by when we say high performance. Is C++ is very good in saving time and space. Yeah.
Finally, the last part is compartmentalize messy constructs. As Anna said, the main weakness of C is it has no classes. So in C++, your goal is to compartmentalize all the messy features so that the user, whoever is using whatever you wrote, does not have to deal with it themselves. Okay? For example, the Stanford libraries, they compartmentalize messy constructs so that you don't have to worry about them. You want to be able to write libraries like the Stanford library. All right? Cool.
Awesome. Yes. So we have 11 minutes left. Perfect.
Other way.
Other way. All right. So we just wanted to give you guys sort of a brief sneak peek into what standard C++ code looks like. So you might recognize sort of these three topics from the slides that we just covered. Again, this is sort of just to emphasize that C++ does in fact support coding in all three of these different ways of coding. And it sort of goes back to the design principle that Avery mentioned of allowing C++ to be as flexible as the programmer wants. C++ does not want to be the reason why you cannot do something. So in some ways that's a blessing, in some ways that's a curse. So sort of just to prove to you guys that we can in fact do all of the above in C++. Right now we are on C++ 17, I believe. So also, pardon me because I don't use a Mac normally, so I might... Oh boy. All right. Let's see.
Should I comment everything out?
Oh yeah, actually I can just comment these out. Yes, okay, perfect. So again, what's happening here, you might be familiar with a main function. If not, it's sort of the place where your program starts. So right now we're just going to be executing this top function right here, which we said is the standard way that you want to print things out in C++. So we can run it with Control R, and let's see what happens. Perfect, and it prints out hello world. All right. And so again, just to prove that the other two methods do in fact work, let's comment these out and try running it again. And perfect. We see that it prints out hello world all three times. This is actually sort of vaguely tricky because this assembly right here only works because it's running on Avery's computer in particular. So if we try to run it, say, on my computer, it might not necessarily work. And again, that's sort of the downside of using assembly, which was the source of all of the modern programming languages. Awesome. So one last thing that we wanted to cover today, we're actually running ahead of time, which is great because it means that we can answer some questions, one of which is already happening. Yeah, go for it. Yeah, great question. What makes the top one the C++ one and the other ones not so C++? That's actually a very good question because that's one of the key things that we want to teach is to use C++ isms is sort of what we call them. And yeah, exactly as you mentioned, sort of what makes this one very C++ is the fact that it's using specific C++ constructs. And there's a couple of them up here. And actually, we can actually go into that right now. How do you increase the zoom? There we go. Okay, perfect. Windows versus Mac users. Yeah, actually, can you guys tell me what in this top C++ method looks unfamiliar to you? What do you notice that you don't really understand right now? Feel free to raise your hand and tell me. What looks odd? Or do you recognize everything? In which case, we can actually we'll probably just cancel the class. It seems like people know. Yeah, awesome. Yeah, that's exactly one. So one is the caret sign. What else do you guys notice? Oh, right here. Oh, yes. Okay, that's a great point. Yeah, good point. Yes, go for it, Mark. Return 0. Okay, that's a great point. Yeah, what else do you not notice? Yeah. Colon. That's a really tricky one. That's a good thing to point out. What else do you guys notice? Yes, go for it. STD. Yeah, that seems odd. Anything else? That's pretty much it, actually. Good job. Yeah, no, awesome. So one of the things you might notice is also, for example, if you came from 106A with Python, if you tried to print hello world, it was something as simple as writing sort of print, maybe parentheses, and then hello world. And to print hello world in C++, it seems like you need all of this additional setup. That's actually a theme that you'll find sort of running through it, is that C++, because it gives you so much flexibility, also means that sometimes you have to write more syntax. But one of the goals of sort of modern C++, as it's changing over the years, is to make some of that easier. So you'll notice in C, it actually looks even slightly uglier. And of course, in assembly, it looks ugliest. So that's sort of like a balance that C++ is trying to maintain. Yeah, so actually, since we have the time, we can even just give sort of a brief intro into all of the parts that you guys just pointed out. So the first one that you mentioned, what's your name again? Julie. The first one that Julie mentioned is the carrots. So have you guys seen the pound includes before at all? Who here has not seen them? Okay, yeah, so pound include you can think about as the equivalent of import in Python. It's the way that you can bring in another library that you've already defined. In this case, the syntax for C++ is pound include. And then there's two different ways to include a library. One that you might have seen before is something that looks like include iostream.h, something like that. Who's seen the .h before? Okay, yeah, perfect. So yeah, that's actually a really good question that I had as well, is what's the difference between these two options? It turns out the main difference is that the carrots are used for any libraries that are standard defined. So in this case, IOStream is a library that has been defined in the C++ language already as part of the standard template library that we'll be going over. And so that's why we use carrots here. The place that you would use quotations is when, as we'll do later in the quarter, when we define our own classes in our own header files, the .h files, then we can use pound include quote the name of our header file to include the files that we've written. Yeah, so that's a very good point. Actually, that's something that gets lost often. Yes, okay. So then other parts that you guys pointed out. One was the return 0. That's actually a good thing to point out. In fact, we didn't necessarily have to have it here. It's sort of, I think this was just mimicking the idea that main as a function typically returns 0. That's actually just a legacy thing. You don't have to worry about it. So yeah, we actually totally could have just removed this return 0 and made this function return void instead. Okay, and then a couple other things that you guys pointed out. The first was the STD, and someone brought up the idea of the standard library, and that being the reason why this is C++ versus the second way isn't, and that's exactly one of the reasons why. Is so cout and endl are things that we'll become very familiar with. In fact, Avery, in our next lecture, will be going over streams. So you'll be learning a lot about both cout, the two caret signs, which are known as stream operators, and the endl. So yeah, we'll be going over those next time. STD : that might be the part that's actually the most difficult for people that are taking 106B right now, is to remember to use the STD, the : the reason for that is that in 106B, you might have seen something that's similar to this, using namespace STD. This is also a preview. We'll be covering later in the quarter why we actually don't necessarily want to use that, and specifically what is this STD used for. As sort of a sneak peek though, the STD is what's known as a scope namespace resolver. And so it's sort of a way of declaring, just as in Python, where when you say something like import numpy as np, and then later in your program you have to write np dot to use a function from numpy. It's the same thing in C++. If you want to use a function from this library IOStream, it's actually, because it's in the standard library, then you can say, yes, I want to use the standard, and then the equivalent of the dot is 2 colons, and then the function cout from that library. Yeah, so yeah, this is sort of the basic Hello World. So do you guys have any questions about it so far? Or anything that we just mentioned about the features that you see here? Yes, Julie, go for it.
Are all standard library header files all part of the STD namespace?
That's a great question. Are all standard library header files part of the STD namespace? Yes. Yes, absolutely. Callable from STD. Yeah, great question. Yeah, any other questions? Yeah, actually, one of our favorite parts about teaching 106L is that we always get really tricky questions from our students. Yeah, so if we don't know the answer, we'll tell you that we don't know, we'll go look it up, and then we'll post the answer to Piazza or something like that afterwards. But yes, we love trying to be tricked or challenged. Yeah, go for it.
IOStream like a small part of the standard library, or is it the entirety?
Great question. Yeah, is IOStream basically is IOStream the standard library, or is it only a small part of it? Yeah, it's actually only a small part of it. We'll show you later on how you can see. In fact, actually, we have. Okay, we only have 1 minute left, so I won't do it. We'll be showing you later where you can see every library that is part of the standard library, so you'll know what's in the standard library, what isn't in it. Yeah, that's a great question.
I'll just finish it
Yes.
up. Okay, yeah. So on the last part, make sure you fill out the survey. It might be kind of annoying to copy this whole thing down. I kind of want to go, because usually when you do this, you have to go through, okay, which one's capital, which one's not capital. But this is also on Piazza. If you sign up for Piazza, the link is posted right there.
Yes.
So fill it out by next Tuesday, and you'll get an extra late day. So just a quick overview of what we're going to next. We're going to start with streams. Okay, so here's a quick summary of what is happening looking ahead. Next lecture, we're gonna go through the top 4 parts. Probably only 3, but we're gonna try to go through the top 4 parts. In CS 106B, I think it's on Friday. On Friday, Keith will cover file streams and the standard library. So that will kind of segue us from IO streams into file streams. On next Tuesday, we're going to go through types and deeper streams, including how do you implement get integer from the Stanford library. Okay? Yeah, and just one final note. You'll notice that what we've been doing is we are going in parallel with CS 106B. So if you're in CS 106B right now, you are definitely ready to take this class. We will follow it pretty closely so that you won't learn anything. We won't assume you know something until it's taught in CS 106B.
Yeah, and again, just to reiterate why we want you to fill out the intro survey, that gives us a chance to know like what your experiences are, so we know whether to go faster or slower, or like what we can base our knowledge on.
Yeah.
So please fill the intro survey out, even if you don't think you'll need a late day.
Yeah. Part of the survey also asks, what do you want to learn? Because the later part of our quarter is, we have some slides from last quarter, but we are also down to teaching whatever you want to learn, okay? So if there's anything on your mind, just write it on the form and we'll take a look.
Awesome. Thank you guys. Happy week 1 of winter quarter.
So if you have any questions, we'll be here for half an hour, maybe less because I want to eat.
Hello.
Am you and the president for the cybersecurity?
I am. Yes.
Yeah, I spoke to some, I don't know if you know some smart.
Yes.
Yeah, and quick question.
Yeah, sure.
Actually, I have a couple. Right?
Your name is Enoch?
Enoch.
Okay.
It's Colin backwards with a K. It's
Okay.
NLK.
Okay, got it.
Yeah, if you, anyway, the third question is, I mean, this is unlikely to happen, but what would be like the difference between just auditing the class versus actually like taking class at
I'm
credits?
so excited.
Sure. Yeah. So the only difference in the class is if you're like officially part of the class, then to get credit for the class, you have to submit 2 out of 3 assignments, including the last one. And then when you submit it, we'll be able to grade your assignment. If you are just auditing the class, you won't be able to submit the assignments. Although if you want to send me the assignment, like I always love chatting about CS to anyone, so you can just send me your assignment and then I can take a look if you want to. Yeah, especially if you're like, oh, I probably don't have time to do 2 extra assignments. Unlikely, but if that's the case, then you can also audit the class. Yeah. Our attendance, we strongly recommend attending, but we don't check attendance or either way. Yeah. Okay.
And do you have your email address?
Yes.
Like
Yes. So if you go to they're on the slides, and then actually I don't know if they're on the slides, but we'll make sure to add it.
later.
It's also on the website, so just go to CS106L, change the B to an L on the CS106B website, and you'll be able to access it. Okay. Yeah. No problem. No problem.
Thanks, Adam.
Hi. Can you remind me of your name? Flynn. Okay.
So when the compiler compiles your code, does it compile it line by line?
Ooh,
Or like
good.
all at once?
Good question. It's definitely not like sequential, because sometimes you have like different function calls going in different directions.
Yeah.
Yeah. So it's definitely not sequential. Although it's definitely a little bit more complicated than Java, because in Java everything is done directly, but then C++, I think it's covered in Keith maybe, but you have to write like the prototypes. Just maybe he's gonna cover it on Wednesday, but in C++, you have to like declare a prototype at the top so that C++ knows this function exists.
No,
Yeah. So it's because of that it's not necessarily done line by line, but C++ has a lot of like weird requirements that we have to put everything.
Then how does the bug checker in like Qt work? Where you can like run it line by line.
Oh, for the Qt one. How does the debugger work?
In Qt, just like how to use it in general.
Well, no, like how if you like compile your program, isn't then it like not line by line? It's like whatever like assembly. I don't know what the
Oh
compiler
wait,
does.
wait,
Like
what was the question again?
Oh, how does compilation work if for
if you want
debugger?
to run like line by line.
Oh, if you're running over it line by line. Yeah, so actually, when you're running it over line by line, that's happening at runtime in your code. So compile time and runtime are sort of two separate stages. So at compile time, you'll actually have already generated all of the code. And then during runtime, there's sort of a separate set of things that happen. So things like variables being written to memory, like the stack or the heap, things like that. And that's what you're sort of accessing when you're in the debugger.
But like when it compiles, it like sort of remembers like which line is which. A little
Yeah,
bit.
yeah. So I think that it's Qt Creator. It takes your code and it also inserts like different things within the code,
Yeah.
so that it like pauses when
So
you
it's like
reach.
an add-on.
Yes,
yeah,
yeah,
exactly.
it'll add more instructions.
Yeah, it basically transforms it so that it allows you to like read
That's an
different parts of the
interesting
memory. Yeah, so if you take CS 110, actually, you implement this thing called ptrace.
Yes.
Right, which is
the same
basically
thing.
which does the same thing, which is pretty cool.
Maybe next year.
What's your name, by the way?
Flynn.
Flynn. Okay,
nice
nice
to
to
meet
meet you.
Sweet.
Hi.
Sebastian.
Yeah, so I was interested in talking more about because you mentioned your systems
Yeah.
and you're
yeah.
interested in cybersecurity.
Yes.
I've recently gained a big interest in cybersecurity.
Oh, really? Okay.
Yeah, I was enrolled in Hack Lab last quarter. And